don't be shy upstairs.
Yeah, and do help yourself to sandwiches, and there'll be Ziploc bags on the leftovers afterwards.
Is there audio hooked up on that? Yeah. I need help. I can share it with your email if you want. Cool, so I'm Rowan Cockett. I'm from 3 Point Science along with a few other people here. And I want to talk just like, so last 2 weeks ago, I guess, there was SciPy, which is the scientific Python community, and I'm sort of involved with a number of hats. With the 3 Point Science side of things, we do a lot of scientific computing. I'm also a grad student at UBC, and there I am a geophysicist, and I have an open source package that I've been contributing to, which is called SIMPEG, which is simulation and parameter estimation. So this is like this growing sort of community project in geophysics, and we sort of sent an army of people down there, and we did like 4 posters and 2 talks, and yeah, it was a pretty good time. And so I just wanted to, so actually all of the there's actually quite a lot of stuff, especially if anyone has sort of an interest in sort of the more numerical sides of geophysics, of Python. And if you go to nthought, I'll post these somewhere afterwards as well. The nthought YouTube channel has all of the videos from the scientific Python conference. And so I just sort of want to go over the highlights that I saw there. So the keynote speaker on the first day was Brian Granger. He's the head of the Jupyter project, or one of the founders of that. And it was sort of an interesting talk. So what I would have expected from a keynote presentation would be sort of an overview of the community and how he got to where he was and all of that. But that was, he introduced instead this new library called Altair, which is for visualization. And so one of the things that he said there was like the visualization space in the Python community is super fractured. There's like matplotlib, there's plotly, there's bouquet, and a number of other ones, and they all have different APIs. And so what this guy, what Brian did with a few other of his collaborators was sort of go to like one of the top research groups in visualization theory about how to do graphs and create like this API pipeline where he does like creates a Python client automatically, and then all of his documentation, and then uses all of these renderers through the same API. And so that's sort of what he was talking about there, which was a really cool talk about abstracting this process and creating a new space for visualization and unifying how we work with visualizations. The second keynote speaker, I forget his name, but it was a high performance computing talk. And this is always like really interesting to see, because if you go to any other like conference, especially in like the scientific conferences, people are still advocating like Fortran and C to write sort of high performance code. And what I think it's Andre was talking about here was writing your code in sort of this very declarative manner. So you say exactly what you want to do, and then how you actually do that, where you sort of get all of your performance out of there, it can be done later. And so we showed a number of examples where you sort of, if you optimize too soon in your code, you sort of, the architecture changes every year, and you lose, well, he showed an example where suddenly you have a performance drop because you optimized too soon for this specific hardware, and then the next year it's some other optimization. And so he was he had this a package called Loopy, which deals with loops in high performance, and he can target various different systems like the graphics card or CPUs or supercomputers and things like that. So that was actually a pretty cool talk. Another thing that came out, and I hadn't heard about this before. How many people here are familiar with the Jupyter project? Okay, so this is something that's happening, I think, more in the science side of things. So if you haven't, and Franklin will show you some of the stuff in his talk using what they call notebooks, and this is sort of a way to interactively go through your code. And so people like data scientists and scientists, you're interrogating data rather than just writing programs. And so you doing this interactively, one cell at a time, and jumping between your different thoughts and having inline visualizations is pretty important. And so this Jupyter organization, which grew out of IPython, which some of you may know more, so this is sort of morphed. And again, this is Brian Granger and Fernando Perez who have done this sort of, who have founded that organization. And the Jupyter is sort of talking to Julia, which is the new scientific computing language. Python and R are sort of the main languages in the sort of open source science community. And this, all of their infrastructure is sort of language agnostic, providing these interactive visualizations or interactive user interfaces to programming languages, which is pretty cool. I don't.
Am I live here? All right. Thanks so much for coming.
So I just want to show you sort of what they're doing next. So they're calling it Jupyter Lab, and so this is sort of a mashup of the notebook, which some of you might have seen and you will soon, IPython, terminals, a file system, and it's all sort of abstracted inside a web browser, language agnostic, and it doesn't even have to run on the same architecture as your computers, so you can connect to a cluster and run it through here, which is pretty cool. And another thing that they were showing is, I think this is, you obviously can't see this, but this is their entire startup script. So each component, this left-hand side, your file browser is one of these things. The notebook is another one. The terminal is another one. And so the way that they've written this is to be sort of infinitely pluggable. Yeah, they're doing a lot of cool stuff. And so this is definitely a talk that I would recommend. Yeah, so we talked about simulation parameter estimation. So we had a number of posters doing a lot of physics simulations and things like that. Another thing that we did when we were down there is launch one of our products called Steno 3D. And so this is an interactive visualization package that has sort of a Python API, so we can, this is a seismic survey through kimberlite pipe in northern Canada. And so this is a mine site that you sort of are throwing a lot of different geophysical methods at. So we were demoing this. It works on an iPad. You can sort of ask us more questions about how this is working. And the package that Franklin will talk about is also sort of a big part of that. And then the last thing I want to just let you guys know is one of our developers who was here last time when we did the Code Dojo on anagram.py gave a lightning talk, and it's a little bit hilarious, so I'd like to show it now.
So yeah, this is a project that came out of something I did a couple of weeks ago. And there was some discussion with people the other night, and it was decided that I should give a lightning talk about it. So yeah, without further ado, this is anagram.py. I was in Calgary, which is a city of Canada. That's where our company's based. And we were doing a Python Code Dojo at one of the local Python meetups. And solution, and then you import the problem. And the problem is already solved on import. Yeah, and so that what this does is it takes a look at the whole word list, and it figures out some of these words are the same letters, but in a different order, right? So we identify which ones are the same, and then you can show all of them ordered by. So you see the ones with the most matches first. It has 100% code coverage, which is pretty great. And I think that this is a solution, or this is a pattern that we can apply to a lot of problems out there. You import the solution, then you import the problem, and that's all you do. So how do we do it? Okay, well first I think we should have a live demo just to show you it works. Right? Yes. And it takes a second. And so we can see what a word list is. Oh, that's interesting. That's a custom class, okay. But if we print it, then something kind of magic happens. And so what we've got is the sorted lowercase version of the stem word, and then any potential matches. You're just seeing the bottom of it there. So if I run this script go.py, and just look at the first 10 lines, you'll see what's happening. And so the word list looks like this. And we keep track of the original form of the word, like case right here, which is important. And so how does this work? Okay, well, first off, I just want to show you 100% code coverage. So that's interesting.
So this is learning from
We
you.
actually do that in one test. and it's pretty robust against failure. Because this is a custom class, so as long as it imports, which is solving the problem, then you're fine. And so, yeah, okay, so the solution. So I watched a talk by David Beasley, which is excellent. It's Python 3 metaprogramming from PyCon a couple of years ago. I suggest you look at it. What this does, there's a custom class here that implements a custom hashing on the lowercase sorted version of the word. So what that means is that Python evaluates that as the same if it's an enterin. And then I subclass set so that it's a callable, so you can pass that through a generator, and it just grabs a hold of things on the way by. Subclass counter to keep track of these things, and then this is an import hook that creates a module and adds something with the same name as the extension to it. Thank you.
Thank you very much.
And it's on GitHub.
Cool. So, anyways, it was a fun time. We had a showing of the Calgary meetup, which was great. So now I think I'll hand it over to Franklin to actually say something real.
So I'm gonna be doing my presentation in the Jupyter notebook that Rowan talked about. So if you want, you can just watch, or if you want to actually follow along, everything's on GitHub